Okay, on to example 6 in section 2.2. Now we're going to break this example 6 into two parts. So we'll do part A and part B first and look for the next video for C and D. But now we're going to do some work with factorials and leaving more algebra in the problem, more n's. And we're just going to try to simplify these statements. So let's look at example A here. So example A is we're saying is n plus 3 multiplied by n plus 2 factorial. So we can change n plus 2 factorial if we want to be, let me give that a little more space, n plus 2 times n plus 1. Remember, the formula or factorial is you multiply n by n minus 1 each time. So that's why we're going down like this. We'll eventually get to n minus 1, and we'll keep going like that until eventually 2 and 1, whenever that is. Okay, so there's nothing to really, we're certainly not going to multiply all of these binomials together, right? We're not going to start multiplying these together, like using FOIL, like you know how to do, because there's, like, this dot 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 is telling us that there's basically an infinite number of those, right? Somewhere in that dot dot dot, for example, there's an n minus 100. So we're definitely not going to start multiplying these together because it doesn't really give us anything. So how do we simplify it? Well, if, let's, for example, look at all of this statement, all of this here, without those square brackets for a moment. So let me write out n plus 3. All I'm doing is dropping some brackets here, and I won't write as many terms this time. Let's just do that. All right. Well, all we've gone from now is, instead of having an n plus 2 factorial, is our first term is now n plus 3. Everything else is the same. So instead of having n plus 3 times n plus 2 factorial, you should see that this looks a lot like, and it looks exactly like, in fact, what n plus 3 factorial would be written out. And that indeed is our answer. That's as simple as this is going to get. We can't actually start multiplying anything in that would be inside the factorial. It doesn't help us in any way. So that's it for example A. So there's really, with this stuff, there's just a couple of little tricks to pick up on when it comes to simplifying factorials. Example B here, 6B, is a more, like, I'll say, classic example of what to do with, or a more classic example of these types of problems, rather. So if you recall, when we were dealing with numbers, the goal was to start with the larger number. Well, here n plus 1 is larger than n minus 1, so we'll start here. Start with larger factorial to simplify. So when we were doing numbers, we'd write out what that factorial is. So let's do the same thing here. I'm going to leave that 3 factorial alone for a moment. And write n plus 1 factorial, or sorry, n plus 1 times n, because the next one would be n plus 1 minus 1, so that's just n, multiplied by n minus 1 factorial. I'm going to stop there because now I have in my numerator the factorial that is in the denominator. So that's 2 factorial times n minus 1. So once I've gotten that to show up, I can just cancel them out. Okay, and in fact, we'll do the same thing with the numbers too, because we've done that before. So 3 times 2 factorial, and I'll leave our n's there for a moment. That's over 2 factorial. Well, now those are going to cancel. So we're left with 3 times an n plus 1 times an n. And now let's multiply all that out. So we'll get 3n plus 3 when we multiply our 3 through our brackets. And then we'll do the same thing again by multiplying each of these terms in the binomial by n. So we get 3n squared plus 3n. Now we've simplified all of this at the start down to just that.